Lesson 10.5 is Trig Word Problems Level 1. I know you don't like word problems, but I think this helps solidify why or how you could actually use the SOHCAHTOA stuff in a problem. Number 1 says, Layla leans a 26-foot ladder. That tells me it's going to be a hypotenuse because it's leaning, that's your angled side, against a wall, so that forms an angle of 61 degrees with the ground. Let's just think about that. A 26-foot ladder against a wall. So ladder is here, that's going to be 26. The wall's here, we don't know anything about that yet. And then it forms an angle of 61 degrees with the ground. The ladder is with the ground. So that's this angle right here. 61 degrees. And then this would be my 90. How high up the wall does the ladder reach? How high? That's your vertical distance. Round your answer to the nearest tenth of a foot. So we have an angle, we have opposite, and we have hypotenuse. So maybe write your SOHCAHTOA. And we're going to be using sine. So it'd be sine of my degrees is the ratio of x over 26. You're simply multiplying by 26 on both sides. Make sure you're in the right mode, which would be degree. And you should get 22.7. That would be feet. All right, number 2, a boat is heading towards a lighthouse. So again, I already stopped. A lighthouse is going to be something that's vertical. A boat is heading. So a boat's here heading in, right, towards the lighthouse, whose beacon light is 139 feet above the water. The beacon light, that's a light at the top of a lighthouse. So that's my vertical height. The boat's crew measures an angle of elevation to the beacon. The boat is here. It is looking up to this light, and it's called an angle of elevation. Angle of elevation is the ground with looking up to something, and that is 11 degrees. What is the ship's horizontal distance from the lighthouse? Boat is here, lighthouse is here. What's the horizontal? So this is my x. Round to the nearest hundredth of a foot. So be aware they change the rounding on you. From here, I have opposite, and then this is my adjacent leg. Opposite and adjacent, that's tangent, TOA. Tan of 11 equals 139 over x. This is one where I'm multiplying by x, then dividing by tangent 11, or I'm going to go faster and swap these so that x equals 139 over tangent of 11. Oop. So then that would be 715.09 feet. That's how far the boat is from the lighthouse. Number 3, Miguel is flying a kite, holding his hands a distance of 3.5 feet above the ground, letting all the kite's string play out. So we have a guy, he's flying a kite, and so his triangle is going to be out from his hands and look like that. So this is not actually the ground. He measures angle of elevation from his hand to the kite. So his hand to the kite. Your angle of elevation again is a horizontal with looking up to something. That's 25 degrees. If the string from the kite to his hand is 150 feet long, the string would be this, because the kite's up here. My drawing skills are not good. How many feet is the kite above the ground? So the problem is that he is 3.5 feet, his hands anyways, are 3.5 feet above. So that's this distance right here. I should have maybe done a curly bracket. So he's wanting to know how high is the kite from the ground. From the ground. So we have to find this and then add 3.5 to it to get the whole thing. So I'll just call this, I guess, y. So from here, I have this and this. Opposite hypotenuse. Opposite hypotenuse is sine of 25 degrees would be y over 150. I'm just multiplying by 150 on both sides. This is the 63.39. But again, I've got to add the 3.5 feet of his hands to the ground to get the total distance. So 66.9 feet. So again, you got to think about what is the bottom of the triangle formed with. Is it with the ground or is it with something up higher? And then you need to add the other height to it. And then last one, from a hot air balloon, Nayeli measures a 35-degree angle of depression to a landmark that's 905 feet away, measuring horizontally. What's the balloon's vertical distance above the ground? Okay, so now somebody, again, terrible drawing. Yeah, not good. Okay, whatever. Somebody is up off the ground and they're looking down. So here's my triangle. 905 feet away. You would not measure something, how far away it is from you from this angle distance. You would say it's this far away from you here to here. So that's going to go down there. And it says measuring horizontally. What's the balloon's vertical distance above the ground? So our angle of depression here, it's very important. Angle of depression is actually a horizontal looking out with then looking down. So this is 35 degrees here. But if you've learned, or if you remember what we learned, that this is a transversal cutting through parallel lines. If that's 35, this is 35 as well. Those are called alternate interior angles. So really, an angle of depression becomes an angle of elevation inside the triangle. So then from here, I have opposite and adjacent. That would be a tangent ratio of 35 equals x over 905, and then multiply by 905. Nearest tenth would be 6.7 feet. So always figure out what is my horizontal, what's my vertical, where's my angle going, and then you're doing the same thing that we've already been doing before.